Introduction. Let us begin. In this module, we will shift from the theory of consumption to the theory of production and will evaluate how the production function is used as a tool in the economic activity. Production is the process of converting the inputs or raw materials into the outputs or the final goods. The rate at which the inputs can be converted into output is governed by the law of production. Law of production are also known as theory of production or laws of returns. Theory of production explains the relationship between the inputs and the outputs and how the change in the inputs leads to a change in the outputs. There are various inputs which are required in the production, but for simplicity, economists have taken only 4 factors of production, namely land, labor, capital and entrepreneur, where each factor of production render its services in order to produce the final good, and in return it is paid factor payment. Since nothing comes free, therefore factors of production also have a cost, and that cost is known as factor payment. Where land earns rent, labor gets wages, capital earns interest and entrepreneur gets profit. Hence, the production of a commodity involves the cost of production, which is in turn the main component of the supply of the commodity. Moreover, cost of production shows the cost output relation, that is, how the changes in the output leads to a change in the cost of production.
Learning outcomes. After studying this module, you shall be able to know the meaning and purpose of production and production function, learn the difference between the short and the long run production function, learn how average and marginal productivity of labor changes with a change in the labor, analyze how output changes with the change in the labor with the help of short run production function. Production function shows the relationship between the output and inputs. In other words, it shows that output is a function of inputs, that is land, labor, capital and entrepreneur, and how the changes in inputs affects the changes in the output. Mathematically, Q is equals to F bracket starts LA, L, K, E bracket close. This is known as the production function, where LA is land, L is labor, K is capital and E is entrepreneur. There can be a number of different inputs to production, that is, factors of production, but they are generally designated as either capital or labor. Technically, land is a third category of factors of production, but it's not generally included in the production function except in the context of a land intensive business. The particular functional form of the production function depends on the specific technology and production processes that a firm uses. Moreover, the production function also represents the technology of a firm, of an industry, or of the economy as a whole. A production function may take the form of a schedule or a table, a graph line or curve, an algebraic equation, or a mathematical model. But each of these forms of a production function can be converted into its other forms. However, for the simplicity purpose, the economists have modified the above production function into Q is equals to F L, K, where the quantity of goods produced, that is, production, depends on labor and capital. Let us now discuss the different types of production function. First, linear homogeneous production function. When all the inputs are increased in the same proportion, the production function is said to be homogeneous. The degree of production function is equal to 1. This is known as linear homogeneous production function. In order to estimate the production function, it is necessary to express the function in explicit functional form. Mathematically, this form of production function is expressed as NQ is equals to F NL, NK. This production function also implies constant returns to scale. That is, if labor and capital are increased by n-fold, the output Q also increases by n-fold. This form of production function is a well-behaved production function, which makes the task of the entrepreneur quite simple and convenient. He requires only finding out just one optimum factor proportions. So long as relative factor prices remain constant, he has not to make any fresh decision regarding factor proportions to be used as he expands his level of production. Moreover, this feature of the same optimum factor proportions is also very useful in input-output analysis. In India, farm management studies have emphasized the constant returns to scale and homogeneous production function. Second, Cobb-Douglas production function. Cobb-Douglas production function refers to the production function in which one input can be substituted by the other input, but to a limited extent. For example, capital and labor can be used as a substitute of each other, but to a limited extent only. Mathematically, Cobb-Douglas production function can be expressed as follows. Q is equals to A k to the power A L to the power B, where A is equals to positive constant, small a and small b is equals to positive fractions, b is equals to 1 minus a. Therefore, Cobb-Douglas production function can also be expressed as follows. Q is equals to A k to the power A L to the power 1 minus a. The characteristics of Cobb-Douglas production function are as follows. First, makes it possible to change the algebraic form in log linear form represented as follows. Log Q is equals to log A plus A log K plus B log L. This production function has been estimated with the help of linear regression analysis. Second, acts as a homogeneous production function whose degree can be calculated by the value obtained after adding values of a and b. If the resultant value of a plus b is 1, it implies that the degree of homogeneity is 1 and indicates the constant returns to scale. Third, makes use of parameters a and b, which signifies the elasticity coefficients of output for inputs, labor and capital respectively. Output elasticity coefficient refers to the change produced in output due to the change in capital while keeping the labor at constant. 4. Represents that there would be no production at zero cost. Third, Leontief production function. Leontief production function uses fixed proportion of inputs having no substitutability between them. It is regarded as the limited case for constant elasticity of substitution. The production function can be expressed as follows. Q is equals to minimum Z1 by A, comma, Z2 by B, where Q is equals to quantity of output produced, Z1 is equals to utilized quantity of input 1, Z2 is equals to utilized quantity of input 2, A and B is equals to constants. Fourth, up next is CES production function. CES stands for constant elasticity substitution. CES production function shows a constant change produced in the output due to the change in input of production. It can be represented as follows. Q is equals to A bracket A k to the power beta plus 1 minus A into L to the power beta bracket close to the power 1 by beta, or Q is equals to A bracket A into L to the power beta plus 1 minus A into k to the power beta bracket close to the power 1 by beta. CES has the homogeneity degree of 1 that implies that output would be increased with the increase in inputs. For example, labor and capital has increased by constant factor m. In such a case, production function can be represented as follows. Q dash is equals to A bracket A into mk to the power beta plus 1 minus A into ml to the power beta bracket close to the power 1 by beta. Q dash is equals to A bracket m to the power beta bracket A k to the power beta plus 1 minus A into L to the power beta bracket close to the power 1 by beta. Q star is equals to m to the power beta to the power 1 by beta into A bracket A k to the power beta plus 1 minus A into L to the power beta bracket close to the power 1 by beta, because Q is equals to A bracket A into k to the power beta plus 1 minus A L to the power beta bracket close to the power 1 by beta. Therefore, Q dash is equals to MQ. This implies that CES production function is homogeneous with degree 1. Significance of production function. First, production function shows the maximum output that can be produced by a specific set of combination of input factors. 2. There are two types of production function. One is short-run production function and the other is long-run production function. The short-run production function explains how output change is relation to the input when there are some fixed factors. Similarly, long-run production function explains the behaviors of output in relation to the input when all inputs are variable. Third, the production function explains how a firm reaches the most optimum combination of factors so that the unit costs are the lowest. Fourth, production function explains how a producer combines various inputs in order to produce a given output in an economically efficient manner. Fifth, the production function helps us to estimate the quantity in which the various factors of production are combined. The following are the important attributes of production function. First, the production function is a flow concept. Second, a production function is a technical relationship between inputs and outputs expressed in physical terms. Third, the production function of a firm depends on the state of technology and inputs. Fourth, from the economic point of view, a rational firm is interested not in all the numerous possible levels of output, but only in that combination which yields maximum outputs. Fifth, the short run production function pertains to the given scale of production. Sixth, the long run production function pertains to the changing scale of production. Now, we will discuss the short run and the long run production functions. In short run, some factors of productions are fixed and some are variable, whereas in the long run, all factors are variable. Thus, a short run production function has inelastic capital, that is, the capital is fixed in the short run, and elastic labor, that is, labor is variable. In other words, output can be increased by increasing labor only because capital is fixed. In the other hand, long run production function, all the factors of production are variable. That is, output can be increased in the long run by increasing either one or both of labor and capital. Hence, in the long run, the supply of both labor and capital is elastic in nature. Therefore, the short run production is also known as single variable production function, and it is termed as Q is equals to F bracket K bar comma L bracket close. Here a bar on capital or K represents that capital is fixed and the producer cannot infuse more capital in the production in the short run, whereas labor, that is L, is variable and changeable. Hence, the law of production under the short run conditions is called the law of variable proportions, the law of returns to a variable input, and the law of diminishing marginal returns, whereas in the long run it is known as the law of returns to scale. The assumptions of production function. Both inputs and outputs are divisible. Only two factors of production, that is labor and capital. Labor and capital are imperfect substitutes. Constant technology, that is technology is given. Inelastic supply of the fixed factors in the short run. Elastic supply of the factors in the long run. Producer is rational. Let us now talk about the law of returns to a variable proportions, that is, the short run law of production. The assumptions of law of variable proportions are as follows. Technology is given, homogeneous labor, and capital is fixed or constant. The law of returns to a variable proportion states that when output is increased by using only one variable input as the other input is fixed, then initially the output increases as an increasing rate, then at a constant rate, and finally it keep on increasing at a diminishing rate. In other words, if more and more of labor is used, then the output initially increases at an increasing rate. When more labor is again infused, then the output increases at a constant rate. And then when again the labor is increased, then the output increases, but it increases at a diminishing rate. The ultimate law is that the marginal increase in total output eventually decreases when additional units of a variable factor are applied to a given quantity of fixed factors. Accordingly, there are three laws of returns to variable inputs. First, the law of increasing returns. Second, the law of constant returns. And third, the law of diminishing returns. In order to understand this law, it is important to understand few concepts first. The production function is measured by total product, average product, and marginal product. First, total product (TPL) is defined as the total output produced with the help of labor. The total product is generated from the total output from the factors of productions employed. It is the quantity of output produced per time period given the inputs. Second, average product or APL is defined as total product divided by the number of labor used in the production process. Third, marginal product or MPL is defined as the additional output produced by employing or increasing one more labor. That is, TPL minus TPL minus 1 is equals to MPL. That is, the marginal product is the change of the total product when there is an additional unit of the input in the factors of production. Hence, given the number of workers and total product, average product, we can derive the marginal product. Consider the table. Let us now know about the three stages in the law of diminishing returns. In stage 1, total product increases as an increasing rate as labor increases. This is indicated by the rising marginal product until the employment of the fifth worker. After that, the fifth and the sixth labor represents a constant return to a variable factor. In stage 2, total product is still increasing, but this time it is increasing at a diminishing rate, which is indicated by a falling marginal product. This stage is hence known as the stage of diminishing returns to a variable factor, as in this stage, when more of labor is used, the total product increases at a diminishing rate. In this stage, the total product also reaches to its maximum, as in the table above. Total product reaches to its maximum at 600 at 10th labor, but when the labor is increased from 10th to 11th and 12th, then the total product started falling and correspondingly marginal product becomes negative. This is known as stage 3 of negative returns. Hence, the three stages represents that the total product initially increases at an increasing rate and marginal product also increases at, but when more labor is used, then it starts increasing at a diminishing rate and marginal product starts falling. But when the total product reaches to its maximum and then when the labor is still increased, then the total product do not increase, rather it falls and correspondingly the marginal product becomes negative.
This can
This
be
can be
represented
represented
in the
in the
diagram.
diagram.
Increasing
Increasing
returns.
returns.
Both
Both
TP
TP
and
and
MP
MP
increases at
increases
an
at an
increasing rate.
increasing rate.
Decreasing or diminishing
Decreasing or
returns.
diminishing
TP
returns.
increases at a diminishing
TP
rate and
increases at a
MP starts
diminishing rate
falling.
and
Negative
MP
returns.
starts falling.
TP reaches to its
Negative
maximum
returns.
and then falls
TP
and
reaches to its maximum and then falls, and correspondingly MP reaches 0 and then becomes negative. Now, let us understand the relationship between average product and marginal product. Increasing returns. Both average product and marginal product increases, but marginal product increases at an increasing rate as compared to average product and reaches to its maximum. Decreasing or diminishing returns. Marginal product starts falling, whereas average product increases at a diminishing rate and reaches to its maximum. Negative returns. Marginal product touches the x-axis, that is, becomes 0 and goes to negative, but average product continues to fall. In other words, the features of the three stages of production may be described as follows. Stage 1. the marginal product of the variable factor, that is labor, is higher than its average product, that is MPL is greater than APL. Stage 2. The marginal product of the variable factor falls below its average product. That is, in stage 2, MPL is less than APL but both remaining greater than 0. Stage 3. The marginal product of the variable factor turns negative while the average product remains greater than 0. Factors behind the law of returns to a variable factor. One of the main factors behind the increasing returns to a variable factor is the indivisibility of the fixed factor capital. It is because when more and more of labor is used with a given amount of capital, then the utilization of capital increases along with the increase in the productivity of labor. On the other hand, if the labor is less than the optimum number, then it results into underutilization of capital and lower productivity of labor, because since the capital is indivisible, so each unit of capital requires an optimum number of labors. Another reason for the increase in the labor productivity is that employment of additional workers gives the advantages of division of labor until optimum capital labor combination is reached. However, once the optimum capital labor ratio is reached, employment of additional workers amounts to substitution of capital with labor. But technically, one factor can substitute another only to a limited extent. Hence, to replace the same amount of capital, more and more workers will have to be employed because per worker marginal productivity decreases, and this leads to diminishing returns to labor.
Slide 39. Let us now summarize what we have learned. The law of diminishing returns is often observed in various production activities but may not apply universally to all kinds of production activities. It may operate at early stage of production in some productive activities, whereas in the other its operations may be delayed, and in some others it may not appear at all. This law is generally found to be operational in agricultural production than in the industrial production, because in agricultural, I repeat, because in agriculture, natural factors play a predominant role as the supply of land is generally fixed, whereas man-made factors play the major role in industrial production. Despite the limitations of the law, if increasing units of an input are applied to the fixed factors, the marginal returns to variable input decrease eventually.